I can at least give you some stuff to do to make it a little more interactive. The computer simulation lab isn't bad. The tennis ball lab isn't bad. So I can do some things with that to illustrate energy. So how can we see energy? Can anybody tell me? What's the first thing I did when I got here today? I unlocked the door and I did what else?
Turn it on.
Turn what on?
The light.
Yes. Okay, so we see energy as light. Okay. We hear energy as what?
Wait. Sound.
Sound.
Vibration.
You could say vibration. There's nothing wrong with that. We're going to be a little more specific in terms of a type of energy. So I'm wearing this because of what? So what's the type of energy we're going to talk about? We're going to talk about heat. Okay. We can use energy when we, sure, walk.
When we go through the day.
Okay, can you tell me something we do during the day?
Breathe.
Breathe. All right. Some of my students, that's really all they do. Move, run, walk, jump. Okay. All right. Breathe is not using a whole lot of energy, but, you know, your chest does go up and down, so I guess we can put breathe. All right. We're not using a ton of energy, though, when we do those things. When we're jumping, running, and walking, we're going to use a little more than breathing. Breathing's not going to get us a lot of money, a lot of energy use.
When you breathe, you act stupid and running around.
Okay. Now, have we got that?
Yes.
Anybody need more time? All right. Were my people who were still writing, are we caught up now?
Almost. Okay.
What's wrong with Logan? All right. Now,
That's what I thought you said at the time of business.
all right, what is energy? Anybody tell me? It's the ability to do something.
The ability to do any possible thing. Or any impossible thing.
It's the ability to do work. Okay? It's the ability to do work. Now, because work and energy are so closely related, their units are also very similar. Okay? They're not just similar, they're actually the same. So we're going to get to that in a second. Now, if an object does work,
it must happen. It must move.
it must use what?
Energy.
Must use energy. Okay? Essentially, you can't have one without what? The other. Okay? You can't do work and not use energy. You can't use energy and not do work. So, because those two things go together, I think I have it on this slide. I do. I thought I did. All right? Because those two things go together, what is the unit for energy? It is joules. Okay? The unit for energy is joules. Now, since we have the test tomorrow, what unit that's on the test tomorrow is also a joule? Okay, it's not watts. Watts goes with what?
Power.
Watts goes with power. Joules goes with work. Okay? So, the unit for energy is a joule, and work is also a joule. So, energy and work are the same unit. Now, you won't see energy on the test tomorrow. That is not on the test. All right, but work you will see on the test tomorrow. So if you see a joule, you should know that joules is work. Watts is power. All right, have I given everybody time to catch up? Do I need to wait on anybody? All right. Now, examples of energy being used. On your review sheet, for anybody who started the review sheet, at the top part, it asked you in question number 5, determine if work is done. Okay? In any of those examples where you said, yes, work is done, what do you know is happening? Energy is being used. So if we said something as simple as throwing a ball, lifting a box, pressing a return key, climbing stairs. Okay? Any of those things that you would answer yes to would be examples of you using energy. But if you answer no, you're not doing work, are we technically using energy?
No.
No. Because you have to do work to use energy. It might feel like we're using energy, but again, according to the science definition, are we using energy?
No.
No. Even though you might have a small child, and you lug them around, and you get really tired, are we doing any work?
No.
Therefore, are we using any energy? No. Okay? Again, that's the science definition. Might be really tiring, but we haven't done anything. Do I need to wait on anybody?
That makes no sense.
I know. All right. Now, the law of conservation of energy says energy is not created or destroyed. It is transferred. This is going to be important if you get to the lab on Wednesday that goes with the roller coaster. Okay? Because we're going to talk about kinetic and potential energy. I'm going to refer to this in what I'm going to teach in the video this afternoon. Okay?
I'm going to stay after you just to ask you questions.
Thanks. Energy is not created or destroyed. It's transferred. So, if we have one type of energy and we use it, if I, for example, kick Jacob, not that I'm going to, well, let's just say I do. The energy I have when I kick him, it's going to be transferred from me to who?
Me.
To Jacob, which is one reason it leaves a bruise and then a sore spot on the person that you would kick, because the energy is transferred to that person. Now, we're going to look at today, and I'm just going to write this here as an example for y'all. We're going to look at kinetic to potential. When I get back from my workshop, we'll look at things like mechanical to thermal. Because y'all are going to look at things like mechanical energy and thermal energy tomorrow after the test. Okay? And we'll talk about those kind of conversions later in the week. Maybe Friday, since it's homecoming day, would be a good day to do that, because that won't require a lot of thought. Okay? Kinetic to potential, though, that one takes a little more thought.
I still can't believe Henderson actually predicted us losing. Yeah, he said that we were probably going to finish the season 7-4. But then he said we finished 8-3 if we really believe we can beat North. What kind of coach says that? Has us losing to North?
Bro, who put North as homecoming? That's what I want.
Beverly and North is athletic. They're
Do we play another game at home in October?
the West game. That's
Oh, we did play another one in October?
senior night.
Okay. Well, that's why if there's only one other home game and it has to be senior night, they didn't have an option. There aren't very many home games in October. That's why they probably were left with that, and then they have West. They don't have another option.
Oh, we only had four home games this year. Last year we had 6. That's why we played South Rowan for homecoming.
Yeah, that's why. There just aren't enough home games.
Homecoming and put
Okay.
North as senior night.
You saying you're going to put North
Senior
senior night? That's going to be embarrassing. You know we're probably going to be the game of the week Friday.
Okay.
For who?
For Lacey versus us versus North Friday.
For which-
Oh,
Which
yeah.
station?
Everybody's voting on it. Fox 8.
Fox 8. This is going to probably going to be the game of the week, so it's probably going to be live on Fox 8.
They don't want to
Okay.
get you up to
Done
that.
it, bitch. Please.
All right.
Please.
This section, the 5 types of energy, I'm just skipping by it because y'all are doing that on Tuesday and Wednesday without me. I'm just cruising on, but whoops, cruise too far. All right, this is the part I need to talk about so that you guys can do the math without me on Wednesday. All right. Now, the formulas are on your reference table. Those of you who have math skills will be fine. Those of you who have weaker math skills will struggle. Okay? So, I'm just being honest. And if I have a chance today, I will video some math problems so you can watch me work those too.
Oh, man.
Not for everybody, just the people who need them. The problem is some of you won't watch and take notes or do it. Now, again, I've told Colonel what a great class you are. Some of you are going to need to watch. So, when you look at kinetic energy, who remembers kinetic energy from middle school? A lot of people do. Every year. Tell me what you remember about it. It moves. Okay? Kinetic energy is very simply energy due to motion. Okay? If you don't remember anything else, when you're trying to figure this out on a test, it must be moving. It drives me crazy when I grade a test paper or a quiz paper and I ask, label which one has kinetic energy and potential energy. And people get this wrong. If it has kinetic energy, it has to be doing what? It has to be moving. If it's not moving, it cannot have kinetic energy. Okay? If it is sitting still, it cannot have kinetic energy. Okay? Now, if I jump over for just a minute, leave some space, to potential energy. A lot of people like to use the definition potential energy is stored energy. I don't like this definition because nobody has any idea what stored energy means. How many of y'all know what that means? Okay? Energy that stays in place. It's not bad. Okay? Energy that you're not using. All right? It's energy based on position. Okay? Now, once we talk about the formula, when we talk about position, we're basically talking about height. If it doesn't have some height, it doesn't have potential energy. Okay? So stored energy doesn't mean squat. Okay? You have to have some position. All right? So, this cup right here is sitting on the floor. Does it have any potential energy?
No.
No, because it has no what?
Height.
It has no height. If I set it on Jacob's desk, now it has what? Potential energy because it has a height. If I move it to this desk, it has more potential energy because it has more what? Height. It has no kinetic energy at any point because it's not doing what? It's not moving. In order for it to have kinetic energy, I need to do what with it? I could throw it, I could knock it so it falls, I could roll it across the room, but it has to do what? It has to move. Okay? Does that make sense? Okay. Now, examples of kinetic energy. A ball rolling. What else you want to put up here? Person walking.
The car moving.
A car moving.
A frisbee going through there.
A what?
Frisbee flying.
Okay, a frisbee flying.
Anything moving.
Okay, all those are good examples. Now, the formula, which we're using tomorrow, KE, or Wednesday, is 1/2 mv squared. That's the way it's written on your formula sheet. Now, a lot of people struggle with what to do with that 1/2.
You put it in parentheses.
You can. All right. I typically write it a different way.
0.5.
I do this. I write it this way. I extend that line over so that the 2 is where? Underneath. So it's easier to solve because now I've gotten rid of that 1/2 that's in the way. So, what is my most important variable there? Which thing do you think affects kinetic energy the most? The mass or the velocity? Why do you think velocity is going to have the most impact?
Because it depends on how far it goes.
Look at just the formula. What's going to affect kinetic energy the most? Why is velocity going to affect it the most? Look at just the formula. Think math class.
Is it squared?
It's squared. If it wasn't squared, they would count the same. Mass and velocity would be equally important. But because velocity is squared, it's more important. So when we talk about kinetic energy, speed is a greater factor than mass because it's a squared number. Okay? But speed or velocity is a greater factor because it's squared. Does that make sense? All right? Now, I'm waiting on anybody to catch up. Raul? Put it on my desk. You don't have it? All right. I was going to say, you look like you're playing on your phone again. So we got potential energy. What's it? All right, give me an example of potential energy. A what? Sure, a ball on top of a hill.
A book. Yes.
Book on a desk.
A painting on the wall.
Hold on, I don't take shorthand. Book on a desk. Ball on top of a hill.
Us on a chair. A painting on a wall.
Us on chair.
Make that look.
Painting on wall. It could be something as simple as, remember when y'all would pull rubber bands back to shoot paper at people?
Yeah.
Y'all got a rubber band pulled back, ready to shoot at somebody. That's got potential energy. Okay? Now, the formula for this one is very different because of the way it's written on the formula sheet. Yeah, she does it all the time. Yes. Now, how many formulas do they give you if they write it that way on the formula sheet?
2.
They gave you 2 formulas. So, what does this mean? Okay?
It means PE equals.
It means PE equals mgh, and it means PE equals FH.
So you get.
Okay? It means you have two different formulas.
That you can.
Okay? You've got to choose the one you want. So, what does the M stand for? Okay? This is mass.
Yeah.
What does this stand for?
Force.
Force.
8 times the height on.
So you have to check the question and decide. Did they give me kilograms or did they give me newtons? And you have to decide which formula to pick. Okay? You have to choose. Does that make sense? Now, what's G?
Wait.
Grounds.
I have failed.
That's
Well,
what
he
did it on purpose. I know.
What is G?
G. G. Oh, I
Well,
got
I
you.
just said that.
G is acceleration due to gravity on Earth.
So what is the number?
9.8 millimeters.
G is gravity.
Meters per second.
G is always 9.8. What is H?
Height.
H is height.
It's
Okay? So, you have to choose, do I have a mass? Do I have a height?
force.
Now, what's the most important variable here? Height. Okay? Because height tells us if we have potential energy or not. If we don't have a height, do we have potential energy?
No.
No. For example, y'all have all been to the playground in middle school, elementary school, right? If the swings are hanging straight down, do you have any potential energy?
No.
What do you have to do to the swing to have potential energy?
Push on.
You got to push it back and let it go to have potential energy. If it's just hanging straight down, it does not have potential energy. You have to do something to give it some potential energy.
They want to.
Okay. When it's moving, it has kinetic. And as it swings, it changes from kinetic to what? To potential. That's what I'm going to talk about this afternoon on the video. It goes back and forth constantly. I don't want that. I don't want that. I don't want that or that.
I'm gonna come just to ask you questions.
You guys said that.
This subject was also.
Okay, that's all.
Yeah. Can't wait.
Wow.
I'm gonna come just to ask her questions.
All right. So let's say that you got to solve this for me tomorrow. Right? Not tomorrow, Wednesday. Let's say this is what you have to solve on Wednesday. Can you do it?
Yes.
Yeah.
In my head.
So the first thing you need to decide after we write it down for those people who are doing it is, what are they asking you for? Are they asking for kinetic
Yeah.
or potential energy?
Kinetic.
Asking for kinetic. Right? That's half the battle. All right, so which letter do we not know? We don't know KE. All right, what's the mass? Okay. What's velocity? What do I have to do to velocity? And then over. Now, before y'all start punching in the calculator, please excuse my dear Aunt Sal. What's that mean? Okay.
Parentheses, exponents.
All right. So parentheses we don't have. Exponents we do. So what do you need to do first on that calculator?
Square.
Square the 10. Okay? So make sure you square the 10. And you don't have to write it down like I'm getting ready to do, but you do have to make sure you do it in the calculator first. All right? Then times 5, divide 2. So 5 times 100 divided by 2 is 250. What unit did we say we put on in energy today? Joules. Questions?
No. What?
Okay? Everybody feel okay about that?
Yeah.
Okay. Remember, you're going to have to do this Wednesday.
Oh, God.
You're going to turn it in for a grade.
Get off the deck.
All right. What about this one?
Oh, yeah. No.
How do we solve for mass?
Oh, I can see. So it would be 50 equals, Can
you let
Hush. Let people write it down.
Shut up, Logan.
Go off my train of thought.
Bree's thinking about getting out of the chair and hitting you over the head with something. Hush.
It would be the first time.
Shut up. God.
All right. So what are we solving for here? All right. I heard kinetic, which is good. So kinetic energy equals mv squared over 2. What variable are we looking for? Okay, we're looking for the m. So I'm going to put my m, I divide it by 2 because those things don't move. Okay? Do I know my KE? What's my KE? 50. Times, what's my velocity? And what do I do to it? Okay. Now, this is where sometimes people run off the rails. Can I divide this 5 squared by 2? No. That's why a lot of times I do this. If I divide it by 2, because we're going to cross multiply and get rid of that fraction, right? 50 times 2 is what? Equals m times what's 5 squared? 25. How do I get m by itself? Divide by what? 25. M equals 4 kilograms. Everybody with me? Huh? I know. Now, we need to do one more because we need to solve for the V. Because what's on the V? And we need to practice getting the squared off the V. It is.
Oh, yeah. I'm right.
That's smart.
Martin. I graduated here from 2020.
Can I turn the page?
That don't sound right.
All right. You don't have to write this one down if you don't want to. You need me to go back, Janai? Okay. You need me to wait while you write? Okay. Now, the potential energy problems work the same way. The only difference is you'll have a height, you'll have a mass, but the problems work the exact same way.
Is potential the only one that has height?
Yes, potential is the only one that has height. All right, so KE equals mv squared over 2. What's kinetic energy? 100. Yes. What's the mass?
50.
We don't know v squared over 2. Now, once you get there, you've done all the physical science. You're doing math. What do we do first?
You cross multiply.
Cross multiply. You always cross multiply to get rid of this. So you've got v by itself. So you get 200 equals 15 times v squared. Divide by 15. Divide by 15. What's 200 divided by 15? Somebody's got a calculator. 13.3. Now, what's the opposite of add? What's the opposite of divide? What's the opposite of squared? So you're going to take the square root to get v by itself. What's the square root of 13.3? 3.6 meters per second. Now, if you will, look around, get my calculators. I see multiples out on counters and various other places. If I don't have them all back in that box at the end of the day, y'all will be calculating for less during the test tomorrow. So round up my calculators. Behave for Colonel Padial. If you have missing work, I will be available again next week.
No. My grade, I need to get 1 grade up, and that's what I have. A's and B's.
Get it up.
Yeah, everybody feels different. Okay.
Let us know for our homework that you would like to get out of school.
Make sure you have your orange cards tomorrow.
Yeah. The Vanna got a 50. Quite easy. Got a 50 something. Yeah, that's how hard it was. But she expected us to get it done. She wasn't.
I need 2 more.
She wasn't on the review. She was there. She expected.
Or my last 2. There's 1. That's my last one. This piece, next time I'm going to keep it and give it to Miss Curry. I'm sure he doesn't.
But how do they expect us to do Texas without wearing jeans? Like,
I have no earthly idea.
like if you're from Texas, you mostly wear jeans. So
I have no idea. I'm not in charge of this.
it's the students' idea. He's stupid freaking.
I'm sure when they created it, they thought they could have jeans.
Miss Turner, go over jeans. I think I had a way to promote myself for Mr. Junior. Like, I'm running for Mr. Junior, so
I hope you win. Good luck.
I'll just do the look. If I do, I'll be surprised. Or everybody else is, because everybody else is. Oh no.